Yeah, thanks for reading out the title for me. So I'm Dennis. I come from the National University of Singapore. So today I want to try and convince some of you as game designers to rethink the way we design games. So as game designers, one of the things that we often strive for is this idea of an optimal game experience. We want the best kind of experience for the players. And one particular theory that's quite popular, and you might have seen it in some of the poster sessions, is this theory of flow by SIGCHI. Right? So the idea of flow is if your game is way too difficult, then your players very quickly become frustrated. But if it's way too mundane, then or too easy, your players will eventually experience boredom, and that is not what we want as game designers. So there's a very nice Goldilocks zone according to the theory of flow, where we will basically match your player skill with the game difficulty or game challenge. So of course, it's not a nice little line that we can stay within. But so as you can see from the graph here, you might sometimes stay within that nice linear line. Sometimes you might deviate from it. But then one of the things as game designers that we can use is this thing called dynamic difficulty adjustment systems. So for dynamic difficulty adjustment systems, you basically use a computational system to help you adjust difficulty on the fly. So this should help keep the players within the flow zone. In current research, however, I think there's a problem, and I hope I don't offend too many people here by saying that we often look at dynamic difficulty adjustment systems with needing to use AI or some smart computational system to do it. So this was one of the motivations of my study. I basically asked this question, well, how else can we adjust difficulty? And a simplistic way of putting it, aside from the computational game system, there are two other possibilities, right? One is the player themselves, and if you're talking about multiplayer games, it can be opponents or teammates. So the focus of this study is on two questions, right? So how do we design for dynamic difficulty adjustment choices for the players? So the players themselves will make these choices. And how do, coming up with designs that allow the player to do that impact the player experience? So we designed a small little experiment to try and, do a little bit of innovation. So what we did was two factors. The first factor is representation of choice. That means where do we put these difficulty choices presented to the players? If we look at commercial games now, a lot of the dynamic difficulty adjustment systems, or maybe not even dynamic, just difficulty systems, they give you menus, right? And there's been existing literature that criticizes such representations. The other factor that I'm looking at is also frequency of choice. How often, if we do, give players this difficulty choice? So if you haven't guessed yet by that odd-looking thing on the corner of my slide, I basically made use of a really popular, well, I'm not sure whether it's still popular anymore, but a well-known game, right? Snake. How many of you have played this game before, or at least heard of it? Good, so most of you. So for those of you who haven't seen it, Snake is a very easy game to play. You play as a snake, and you move around, an enclosed space trying to collect food. And the more food you collect, the faster you go and the longer you grow, right? And that's it to the game. So we have a 3x2 within subject, counterbalanced, of course, game design. And we made our participants play 3 games for each condition. So they had to play a total of 18 snake games altogether. And then at the end of playing those games, we basically measured the 9 components of flow using Jackson and Marshall's flow state scale. Okay. So how do we do representation of choice then? We operationalized it by having 2 things, embedded and non-embedded controls, right? So for non-embedded, we basically provided your keyboard keys, Z and X, to adjust for difficulty. And what we had was a small little note at the top that tells you when you can make that decision. Then, of course, we have embedded mechanics. Some of you might notice this is a bit similar to General Verchen's actual game flow, where we have the different choices of difficulty embedded within the game as part of the core game mechanic. And then, of course, we tested these two and compared them with each other. So in terms of frequency of choice then, we decided to try the extremes, right? So we started with ones. We only presented the choice at the start of the game, and then it disappeared after about, if I remember right, 15 or 8 seconds. 8 seconds actually. Yeah, and then we have periodic choice, which means that after you have made a choice, shortly after, you will see the choice again. And then the last one is constantly. So immediately after you make the choice, the next choice pops up. Okay. So I'll just go to the findings. If you want to read up more about the flow state scale, refer to our paper, refer to the papers before that we referenced as well. Okay. So our first finding, whether we should embed or not to embed difficulty choices, we actually found that using embedded choice, players are more likely to experience two things, at least in the context of our game. So spontaneous or automatic actions, which we call action awareness merging, as well as an altered sense of time. But more importantly, we did not find any negative impact on the game experience, right? So try to use embedded choices. Of course, it depends on what kind of game you're doing, as we have discussed. Depending on what kind of game you have, there might be other effects. So I'll discuss that later on. So is once enough? In our study, it is actually not enough, right? Because if you compare our periodic condition with the once condition, out of 9 dimensions that we measured, 5 of them were significantly improved, and they are quite important dimensions if you look at them. However, there was one that was actually diminished, which was unambiguous feedback. So the interesting thing here is that providing more choice within the game itself might actually lead to, this ambiguity of what is the game trying to tell me. Okay, so can there be too much choice? In comparing constant with the once condition, it was marginally better, right? So we have 2 components that were basically improved, and 1 component, action awareness merging, which is an important one, that was deproved. But for constant and periodic comparison, 3 dimensions were diminished. So yes, there can be too much choice sometimes. So this is an interesting thing that I would like to discuss if there are any psychologists or cognitive scientists within this room. I'll try and speculate a little bit on that later. So this is the most interesting finding of our paper, is that if you use both together, meaning where you put the choice and how frequent you provide choice, there's actually an interaction effect. So as you can see, if you have embedded and constant choice, which is this one, right, instead of having improved clear goals, you will basically have a very large drop. Right, so we speculate then that the players might be actually torn between trying to play the actual game and figuring out, should I be making a difficulty adjustment at this point of time? So when constant choice is required, if you needed to use it, you might want to consider direct control instead because of this drawback. So another thing that we didn't expect to find was when we use embedded with periodic conditions, there was actually a loss of self-consciousness. So this is the part that I was talking about. We believe that by having periodic choice in the game mechanics, it actually makes the choice much more important to the player, because it seems as if when the player looks at the icons that appear on the screen, suddenly they have this time frame where they need to make this important choice of, am I doing well? Do I need to make this choice right now, right? If I don't do it now, then the game may be too difficult for me, and so on. So that is basically how we try to explain this. And of course, if you have an embedded mechanic design, what this means is you have to work with the mechanic itself. So for example, in this case, you have to move the snake to the actual food that increases or decreases the difficulty. So in conclusion, there are a few takeaways here. So we really need proper design of difficulty choices, right? Right now what's happening is we kind of have these interactions where players make choices within our games, changing the difficulty as an afterthought. And sometimes it's good, sometimes it's bad, sometimes we don't even know what happens at all. Of course, embedding difficulty choices is generally recommended, but I would like to exercise a bit of caution here. It really depends on the kind of game that you're making. But it is clear that one choice is obviously not enough, right? So for game designers who are looking at, letting the players select a difficulty choice only at the start of the game, you should probably rethink that as well. And then finally, when you are designing for player choice, you should be cautious of unintended effects. So as I've shown, if you have representation with the frequency of choice, you might have unintended impacts on the player experience. Okay, so that's it for my presentation. Thank you very much.
Okay, we've got time for 2 questions just before lunch. Daniel?
Daniel Johnson, Queensland University of Technology. Thanks for the presentation. I'm really excited to see more people doing some DDA stuff. And so my question's not loaded, but it might feel that way. We've used that flow scale a lot, and we've pried ourselves into pretzels quite a few times trying to explain results that didn't make sense, and eventually went, I don't think Jackson's flow scale works that well in games. Does that resonate for you at all? Like, do you have any sense of that being possibly...
So right now, at least in terms of my experience, and I have revalidated the skills again for this particular study. 2 years ago in Kai Play 17, I actually used the flow scales as well to test the fundamental assumption that we can use such scales to measure the flow experience in games. So for that one, I basically used Tetris, and there was a very nice effect that we can see, and it's pretty strong as well. So what you might be experiencing might come from the games themselves. You have to be really careful, and that explains why I'm using such a simple game, because previously we wanted to use way more complex games, obviously because of external validity. But we realized that there are things that you don't often associate with it might impact these player experiences, but it turns out that it confounds the entire experiment. So maybe that's something that is worth considering.
Let's chat about it, because I'd love to.
Yes.
If there's not a second question, I've got a follow-up question, but I'll shut up and we'll...
Okay, is there a second question?
I can't
It seems you're on.
More time.
So for me, then the curious thing is, what do you think it is about? Because we used more complex games every time it kind of went weird on us. Do you have any speculation on what it is about the more complex games that makes the scale stop working?
Right. I think it's a really complex question to answer because it depends on what kind of mechanics that you are putting within the game. From my own observations, I haven't done any official studies on this, but depending on the kind of mechanic, for example, whether or not there's dynamic difficulty adjustment, players may feel, for example, that there's transformation of time. So someone in here was playing that VR game where you had to do some weird navigation of a player down a slope and skiing or something. You had to lean forward to play it in VR. And just by having mechanics like that, right, because you don't usually move your body like that, there might be effects where you feel as if, oh, time is being slowed down, even though there's no dynamic difficulty adjustment in this case. Yeah.
Thanks, Dennis. Looking forward to chatting more about it.
Okay, and with that we close the session for lunch. Thank you.